Hello, my name is Caitlin Lim, and I am going to present the StockFlow Tutor as a demo. This was originally created using the CTAT authoring tools for the LearnLab Summer School 2020. It was presented on July 31st. You can see right here we have a StockFlow problem. The graph below shows the number of people entering and leaving a department store over a 30-minute period. Our first question: what represents time in minutes? Taking a look at the graph, it should be the x-axis. The next question: what represents the rate of people per minute? I take a look at the y-axis. That looks like people per minute. So it should be the y-axis. Great. During which minute did the most people enter the store? I'm not quite so sure. Maybe it's going to be right here because that's when the peak for leaving. So 21 maybe? No, it's not 21. Let's look at my feedback. Take a look at the black line and think about what the x and y axes represent. Okay. So the x-axis represents time. Okay, so that's the rate of people entering the store. So that should be here, number 4. Great. During which minute did the most people leave the store? This time I'm going to ask for a hint. Take a look at the red line for people leaving. Your answer will be a whole number. Okay, so I'm looking at the red line. Oh, that one must be 21. Great. During which minute were there the most people in the store? Well, my first instinct is I don't know. I guess I'm going to get a hint. Okay, so thinking about the relationship between when people enter and leave. I'm guessing if I want the most people in the store, that means the most people entering and leaving and the biggest gap between the two. So I'm going to guess 8. Oh no, it looks like that was wrong, but I got some more questions now. When do we start to lose people? I'm not sure. Let's get a hint. Okay, I need another hint. Think about how the y-axis is given the rate of people per minute. So if we're losing people per minute, that means maybe it's going to be 21. No? Why not? Okay. My next guess would be 13. Oh, hey, that's when we started to lose people, was at 13. So when do we start to gain people? How about at gaining people? That means there are people entering less than leaving. I guess that would be 0. Awesome. From 0 minutes to 13 minutes, what does the area under the entering line and above the leaving line represent? Number of people, rate of growth, rate of decline, it doesn't matter. I think it doesn't matter. No, that's wrong. Think about what the graph means when the y-axis is. Oh, this is like math. The derivative is, let's get a hint. This is like math. Oh, that's not a good enough hint. I think the derivative is the amount. So the amount would be the number of people. Yes. What time period has more people? So it's either before or after 13. I think, so if the area between the two curves is the number of people, the number of people coming in would be here and the number of people leaving here. So it definitely has to be the one with the people coming in. So it definitely has to be 0 to 13. Great. So now I guess I have to do this one again. I see 13 twice, so I think it's going to be 13. Great. And during which minute did the fewest people leave the store? Wait, the fewest people in the store, not leaving the store. So if it's the fewest people in the store, it's gaining, 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 losing, 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 losing. Let's get a hint. No, that doesn't help. Oh, this looks helpful. When the rate of people leaving the store exceeds the rate of people entering store, the overall number of people in the store begins to decrease. When does the overall people store decreasing? Oh, okay. So I guess that would be 30. And we are done. So obviously I've done this problem quite a few times, and it was a lot of work to make. It seems like a pretty simple interface, but we actually did all of this by hand. I realized later on that we should have done it using JavaScript. So the way we started was in this authoring, in this behavior graph, we started by making all of our values false. This effectively hid all of the questions. So at this true start, this is when our graph will be empty except for those two beginning questions. Then after we answer the x-axis and the y-axis questions, it'll be time to unhide question 1. So you see I have to unhide the question as well as the answer box. In my behavior graph, you can see that we will give different feedback if they get the incorrect or the correct answer. This is the same all the way up to when you answer question 3. So when we're answering question 3, we can either activate those supplemental questions that you saw in the demo, or we can make it so that we don't have to activate those questions. If I were to type in the correct answer right here, we skip over all of those supplemental questions. The goal behind the supplemental questions was to scaffold the learning. This problem is notoriously hard, and a lot of people have trouble, especially with that third one. What does it represent? If they can understand what number of people is represented by, in this case, it was the area of the graph, I think that people would be better at answering this question. Of course, there are some people who understand that, but the majority of people do not. And you can see right here, when they're retrying question 3, they actually get pretty detailed feedback on the incorrect answers. For instance, let's say I entered 9. At this moment, we indeed have more people in the store in the beginning, but the stock is still increasing since the entering rate is higher than the leaving rate. Okay. So you see there's the detailed feedback, and then with question 4, we had the other stuff as well. And then at the end, we're done. So that was the demo of our tutor. Hopefully in the future, we could improve on things such as the design. This is a rather plain design, and I think it probably could be designed better. We could also work on the knowledge components if we were to track what students knew, especially with that inner loop, then I think that would improve. Also, some of the feedback isn't great. We could improve that, as well as when they get question 3 right, but question 4 wrong, we don't activate those additional questions, which we really should. And probably the biggest thing that I would improve on is doing this in JavaScript, because that way this behavior graph wouldn't be so messy. This was the first time I used CTAT. I did the majority of the building, such as the front end and a lot of the nodes on the back end. My partner actually led the way on the comments. She wrote all of those comments and put them in for me. So that detailed feedback is what she provided, and that was very useful. Thank you very much for watching.